So any of the predators that are down here are pretty much going to rely on vision for hunting their prey. And the prey are going to try and avoid being eaten. And they're mostly going to use camouflage to try and avoid being eaten because the spines and defensive structures are too heavy and too energy costly. So they don't have them. So camouflage is their best bet. The methods of camouflage that they are going to use are going to be pretty much the same as the methods in the epipelagic zone, but again, going to look kind of different. So you will have counter shading. So you will have fish that will have backs that will be black, okay, rather than like blue. Because when you look down in the water, down towards the deep sea, it's going to look utterly black. And so the backs of these fish are going to be black. The underside is going to be like a silvery color rather than like white, because the white would be pretty more obvious if you looked up towards the surface, whereas the silvery is going to kind of help blend in better. So they'll be counter shaded, they'll just have different colors than the epipelagic zone with black and silver. You also have animals that will be transparent. So they'll be see-through, so hopefully your predator looks right through you rather than looking at you directly. So they will be transparent. This is kind of cool. So deeper in the mesopelagic zone, down here and then into the deep sea, you're actually going to have fish and krill and stuff like that that are like bright red or like bright purple or black or like this weird white color. The reason for that is because light gets filtered out before this depth. So here, let me explain how you actually see, and then we'll explain what happens. So like Robbie's sweatshirt looks red to us because the visible spectrum of light hits his sweatshirt. Okay, the red dye in his sweatshirt absorbs all of the colors except for red. Red bounces back to your eye, and you see the color red. Down here, red light and other colors of light get filtered out up here in the epipelagic zone. So the red light never makes it down here. So you could be a krill that's bright red, but there's no red light to bounce off of your body and go to your predator's eyes. So they can't see you. So you pretty much just look black. Does that make sense? So that's kind of cool. When we pull these animals up, they look like all of these brilliant colors, but that's because they're up at the surface and we can actually use light to see them. But down there, they just look completely black, which is kind of cool. They will also still have like a silhouette. So even if they're like counter shaded and stuff, if a predator is looking up at them, they'll still be able to see like the outline of the body of the fish from below. So they will actually try and reduce that silhouette as much as possible, or reduce that outline by like being laterally compressed so that they produce as little of a silhouette as possible, so that the predator hopefully won't see them. So here's some pictures of this. Transparency. So this little krill here is transparent, so the predator hopefully sees through it. This is a counter shaded fish with the black on the top and then the silvery on the underside. You see that? And then here's your hatchet fish. You can see the big tubular eyes, and then you can see laterally compressed, yeah? Compressed from side to side.